So physical changes are there when the thermal stress is applied on an object or a substance. Anomalous expansion means it is a unique property which a water actually gives. An isothermal process is a one in which the temperature is kept constant and there is change in pressure. Gamma is the ratio of two specific heats at constant volume and constant pressure. Hello everyone, I'm Vrinda, Faculty of Physics from Vidhyaashram Pre-University College, Mysuru. Welcome you all to the session 2 of chapter 11, that is thermal properties of matter. So in today's chapter, that is in today's session, let us study regarding the thermal stress and how the expansion takes place in a solid or liquid when the temperature is applied, and all the laws, that is gas laws, what is ideal gas equations, that is what is meant by ideal gas and its equation, and the anomalous behavior of water. So now, first of all, let us move to measurement of temperature. So in last session, we had discussed, so what is used in order to measure the temperature? The instrument which is used in order to use the temperature is nothing but thermometer. It is thermometer. So here we calculate either in degree Celsius or in degree Kelvin. In degree Celsius you have 0 to 100 degrees Celsius, wherein its melting point starts from 0 degree and boiling point reaches up till 100 degrees Celsius. So how many equal divisions are there? There are 100 equal divisions over here. When you compare that to Fahrenheit scale, 32 degree Fahrenheit will be your melting point of the ice and 212 degree Fahrenheit will be your boiling point of water. This is in Fahrenheit scale, whereas the above one is in Celsius scale. So this is how we use the thermometer, that is the temperature. The heat which is within an object is transferred from one part to the other part. So suppose if we keep the thermometer inside our mouth, what happens? Our body heat is produced, that is heat is transferred from a body to the thermometer. That is how we get to know our heat of the body. So that is all about the measurement of temperature. Now, having these concepts with us, let us see what exactly is meant by a thermal stress. So here we are talking about thermal stress, that is thermal. Thermal means something, whatever we're talking about a temperature, and stress is nothing but the pressure which is exerted. So thermal stress, that means the temperature exerts certain stress on the object. So there is change, that is a variation in its components of the object. So the changes takes place physically. So physical changes are there when the thermal stress is applied on an object or a substance. So here in this case we have thermal stress is equal to, so what is meant by a stress? Stress is nothing but force which is exerted per unit area. Stress is also nothing but the pressure. So it is a force exerted in that area, that unit area. So it is known as force per unit area developed when thermal expansion or contraction is resisted. Here, when there is the thermal, that is the temperature application, either contraction or expansion takes place due to the temperature, what happens to the object? It undergoes a force per unit area, and that stress is nothing but the thermal stress. Having this thermal stress, let us get into detail about it. That is, let us go to some practical effects which explains the expansion in the solids that is due to thermal stress. It is like I told you, thermal stress means the stress which is exerted on an object, and it is a physical stress, correct? So when the stress, that is when a pressure is applied on an object, when the temperature is either increased or decreased, what happens to the object? It undergoes physical changes. So some of the practical aspects are there which we see in our daily life, but we never identify things. The practical aspects in our daily life is as follows. Suppose if you have seen tracks, railway tracks. So there in railway tracks, that is In rails on the railway tracks, there is a small space are left between two consecutive rails. Very minute space which is left between two consecutive rails. So that is in order to allow the expansion when they get heated. Due to the atmospheric condition, it is not that heat is produced artificially. It's a natural process as well. When the atmospheric condition changes, that is during winter, rainy season, summer season and spring season, like so and so. When this is the thing, what happens when there is a summer, that is when they get heated during summer seasons. Rails over there which is present in railway tracks, it starts expanding. So suppose if there is no space, what happens? It merges and it will be crooked. The railway tracks will be in different shape. That is why in order to lessen those things, these railway tracks are provided with certain gaps. That is all about your first point. And the next point is telegraphic wires and electricity transmission wires are hung down loosely to allow for contraction during winter. So during winter, that is change in the temperature. Okay, I'm not telling only increase in temperature. This is always used for the changes in temperature. It might be increase or decrease in temperature. Okay, so what happens to the electrical wires or the telegraphic wires which is hung down? It is loosely hung down. Why? That is because during winter, what happens to the wire? It starts contracting. Okay, and when the heat is produced, what happens to the wire? It loosens itself. So that is why sometimes we see the wire is stretched tightly or else it is hung down according to the seasonal change. Suppose if we don't hang it loosely, what happens? There will be contraction and later which leads to the breakage of the wires during winter when it contracts even more. So this is the logic behind the telegraphic wires as well as electricity transmitting wires. And the third point is hot water is poured on the metal cap of bottle so that the cap starts expanding. Okay, in order to open the cap, what are we supposed to do? We have to heat the cap, that is hot water is poured on the cap. So its temperature increases. When the temperature, that is the thermal stress is applied on the cap increases, what happens to the cap? It starts expanding and we can easily open the cap of the bottle. So here these are all about the practical aspects which is related with the expansion due to thermal stress. So there are two types of expansion. One is real expansion and another one is apparent expansion. Suppose if you consider a thermometer bulb which is like the round bottom flask and there is a presence of certain liquid, that is a component fluid over here. And when the less heat is produced, what happens to the molecules of the fluid? The liquid that expands when heated, which is given over here. That means the liquid expands when it is heated. But since it is less heat is produced over here, we can't see much more of the expansion. So when during initial stage, when the heat is produced, what happens to the liquid? It comes down. That is, if suppose to this you fill, that is A, is the layer to where you fill the fluid. So it will be A. Suppose if you consider B, this B is nothing but once the heat is produced, what happens to the thermometer bulb over here? The thermometer bulb starts heating up and the vessel start heating but not the inner quantity. That is, the fluid doesn't start heating up at the beginning. So what happens to this fluid which is present over here? It comes down to point B. And when we produce more and more of heat, what happens to the fluid which is present over here? It starts expanding. So there is certain expansion which is given over here when the heat is more. So this expansion, name it as C. So here you had your A, here you had your B, and here you had your C. So this change from A to C is said to be apparent expansion. So this is said to be apparent expansion, whereas from B to C on the whole is said to be real expansion. So this is all about your thermal expansion. So having these concepts as a base, let us see regarding the anomalous expansion of water. Why only water and not liquids? Anomalous expansion means it is a unique property which a water actually gives. It is like if you increase the temperature of any liquid, what happens? Just imagine you take a beaker, pour any liquid on it, start boiling that liquid. What happens to that specific liquid which is present in the beaker? Its volume starts increasing and its density decreases. But here in the case of water, when can you say that the water is formed? When it starts melting. And the melting point of ice is said to be 0 degrees Celsius from where it melts. So that condition is known as a water. It is forming a water. So any liquids, when it starts getting heated, that is when a thermal stress is applied on it, it starts, that is its volume starts increasing from 0 degrees Celsius to 100 degrees Celsius. It keeps on increasing. But in case of water, it shows a different change. I told you in liquids, it is the volume increasing, density decreases. But in case of water, from 0 degrees Celsius to 4 degrees Celsius, the volume decreases, its density starts increasing. Okay, it shows some of the unique behavior. Which one? The water. Okay, so it shows volume decreases, density increases. After 4 degrees Celsius, it behaves as same as that of the liquid. That is, after 4 degrees Celsius, its volume starts increasing, density decreases. So this is the objective of this anomalous expansion of water. It shows an anomalous behavior. So you can conclude it like it contracts, that is the water contracts from 0 degrees Celsius to 4 degrees Celsius, the water contracts, that is the volume starts decreasing, density increases. But above 4 degrees Celsius, you can say that the water expands. So this concept is said to be an anomalous behavior of water. So here, why have I given this image over here? That is because there is a concept for us to study in the aquatic life which remains underwater, that too specifically in the water which is in ice region. Okay, that is a cold region. What happens in a cold region? There a lake or any reservoirs will be covered with the icebergs, correct? So the water which is present over the top, it acquires 0 to 4 degrees Celsius, and what happens to the water which is above, that is the first layer, superficial layer, its volume decreases, density increases. When its density increases, it comes down. That first layer, superficial layer, sinks down, and the layer which is having lower density comes up to the first layer. It will take up as a first layer. And now again, it takes up from 0 to 4 degrees Celsius. Again, volume decreases, density increases. Again, the second layer which had come up, taking the superficial layer, it comes down. Again, you get a new layer which has certain temperature, and due to the surroundings, 0 to 4 degrees Celsius, so it lies between 0 to 4 degrees Celsius, volume decreases, density increases. Again, it gets back downwards. Same way, each and every layer interchange each other, and finally at the end of the day, after the complete interchange, the last layer which stays above as it is, it stays above. There will be no more interchanging. Okay, so whichever layer is lying below, that is the last layer which has occupied the higher density, and it stays there itself because no further interchange will take place, that layer will form a iceberg. It will be very cold. The further depth of the water will be having certain temperature which will be above 4 degrees Celsius. Here you will have the temperature above 4 degrees Celsius. So after which You can see the volume expands and density decreases at this stage. So here the aquatic life is easier. So we just imagine how will the aquatic creatures stay themselves inside the ice waters. That is due to their adaptation under anomalous behavior of water condition. Okay, so I hope you're clear with what is meant by anomalous behavior, and here in an easy way I have explained it to a practical concept of a daily life. So next is isothermal process. So what is meant by isothermal process? Here just keep in mind, for a shortcut you can just remember isothermal means you're isolating the temperature. So when you're isolating the temperature, it is like isothermal process is one in which it contains pressure and volume and you're isolating temperature. That means you're keeping temperature constant, wherein there is variation, that is there is changes in pressure as well as volume. So this you have studied in your previous concept, and that concept is nothing but your Boyle's law. Okay, Boyle's law also, at constant temperature the pressure is inversely proportional to volume. It was like that. So similar way it goes up here, that is isothermal. You're isolating the temperature. That means you're not removing and just throwing it off. It is just that you're keeping temperature constant. This is just for you to remember. I have given this shortcut, that is isothermal process, isolating temperature. So here an isothermal process is a one in which the temperature is kept constant and there is change in pressure and volume, which can be given as PV is equal to constant. Suppose you consider a liquid which is having pressure P1 at volume V1 and pressure P2 at volume V2. What will be the equation which is given for this isothermal process? It will be P1 V1 is equal to P2 V2 respectively. Consider a cylinder which is a good conductor. So if this is a cylinder which is a good conductor and certain fluid is present over here which is given a frictionless piston. It is provided with a piston which is used in order to compress inside the cylinder, either it is gas or it is a liquid. So if you consider this as a good conductor and this is a frictionless piston, when you just give a pressure to the piston, what happens to the components which is present over here? It starts compressing. That is, there is an increase in heat. The temperature increases. But what was the condition in isothermal process? It is like the temperature is kept constant. In order to maintain the condition which is given above, that is constant temperature, instead of applying a super fast work, you can slow down that work. That is, slowly the component which is present in a good conductor is compressed. So a slow compression is applied to this conductor by a frictionless piston. So this is how you can maintain the interior, that is the temperature of the conductor as well as the surrounding temperature. There won't be any increase in such sort of a temperature over here. So what is isothermal process? Pressure as well as volume changes are taking place, but the temperature is kept constant. So experimentally, what do? We just slow down the work which we are doing on the conductor by frictionless piston. On contrary to this isothermal process, we have got an adiabatic process. So here in this case of adiabatic process, it is a process in which the pressure changes, volume also changes, but we can't say that the temperature is constant over here. That is, It takes place in complete thermal isolation with the surroundings. That is, there is a thermal isolation with it isolates itself from the surrounding. The temperature of any of the cylinder isolates itself from that of the surroundings. So once again, I'll be considering insulator here. In the previous isothermal process, I had considered good conductor, okay? Why I am considering insulator? Because I should isolate myself from the surroundings. That is why insulator is the best one in order to explain adiabatic process. So here we have got insulator, which is containing some components, and it is provided with a piston which is used for compression and expansion. Suppose here in adiabatic process, compression and expansion process takes place. What happens during those time? So suppose if you consider like expansion and compression, there is a temperature change between itself as well as its surrounding if the work is super fast. I told you it is all about thermal isolation, means there is no exchange of heat. Neither a new temperature enters nor the temperature which is increased over here leaves. Okay, so that is all about your adiabatic constant, which is given by PV gamma is equal to constant. So we have at pressure P1 and at pressure P2, we have volume V1 and V2, which can be given as P1 V1 gamma is equal to P2 V2 gamma. So when this is the case, what is meant by gamma? Gamma is the ratio of two specific heats at constant volume and constant pressure. So we have got gamma is equal to Cp by Cv. So this is the elaboration of gamma. So here, adiabatic process, practically speaking, when the work is done, there will be no time for the exchange of the gas. So that is all about your adiabatic process. So isothermal process, isolating temperature, that means temperature is constant. Adiabatic process, here thermal isolation is taking place. Thermal isolation in the sense, it is not even taking an exchange between the surroundings temperature as well as the temperature which is within itself. So these are all about your isothermal process and adiabatic process. And we have already studied certain gas laws. That is Boyle's law, Charles' law, Gay-Lussac's law. So I hope you know this Boyle's law, Charles' law, Gay-Lussac's law, wherein Boyle's law states that at constant temperature, the pressure is inversely proportional to volume, which is given as PV is equal to constant. That is all about your Boyle's law. And Charles' law states that at constant pressure, volume is directly proportional to temperature, so it becomes V divided by T is equal to constant. And Gay-Lussac's law states that at constant volume, pressure is directly proportional to temperature. So these are all the concepts of Boyle's law, Charles' law as well as Gay-Lussac's law. Having those concepts, isothermal process and adiabatic process, now let us go on to the specific heat capacity. So as you all seen, you have got certain heat for each and every object. So each and every object possesses certain heats. So it has got certain capacity that it can take up the temperature. So these are nothing but the specific heat capacity of certain objects or a substance. So here we are talking about the liquids. So the specific heat capacity can be given as the heat which is supplied to a substance, the quantity of heat required to raise the temperature of 1 unit mass. The quantity of heat which is required in order to increase the temperature of 1 unit mass of the substance through how much is the temperature's value? 1 Kelvin. Okay, the heat which is supplied to a substance so that its temperature increases by 1 Kelvin. Okay, the heat is supplied to a substance so that its temperature increases by 1 Kelvin and the substance is said to be in the mass of 1 unit or a unit mass. Okay, so again let us read it. The quantity of heat required to raise the temperature of unit mass of the substance through 1 Kelvin is said to be specific heat capacity. Suppose you consider molar specific heat capacity. Definition is the same, but you're adding heat to what is the main term over here. That is like, you're talking about specific heat of the substance, the same definition, but you're talking about molar specific heat now. So when it is molar specific heat, you're talking about the moles which is produced in a substance. It is like heat required to raise the temperature of 1 mole of a substance through 1 Kelvin. So you're talking about 1 mole. Just 1 mole is added from the previous definition. So what is molar specific heat? The heat which is required by a substance, that is 1 mole of a substance, to increase its temperature by 1 Kelvin. That is all about molar specific heat. Coming to the last point, that is heat capacity. What is meant by a heat capacity? Heat capacity means the quantity of heat required to raise the temperature of certain quantity. That certain quantity can be unit mass of a substance or 1 mole of a substance. Anything can be added over there of a substance through 1 Kelvin is known as the heat capacity. So these 3 are the important definitions and it is very easy to understand what exactly is meant by heat capacity of any substance. It is like you're producing heat in order to increase its temperature by 1 Kelvin. I told you the difference between heat and temperature in my last session, so you just can go back to it and get the difference between heat and temperature and you will easily get the concept of specific heat capacity. We have discussed about the specific heat capacity, isothermal process, adiabatic process, and the thermal expansion in solids as well as in liquids. And as you all know, what is meant by an ideal gas? Ideal gas is the one which obeys Boyle's law and Charles' law, which was discussed earlier in session 1. So this is all about your session 2. Now let us all meet in the session 3 in our next class. Until then, have a good day. Thank you.